Hello students, let us discuss counter type A to D converter. So a to D converter converts analog input into digital output. So if you give a analog voltage, okay, then you can get equivalent digital output. So if you see the main component of a counter type of A to D converter, so the main component is a comparator, then you have a counter, then you have a D to A converter, a diode, a control unit, and a latches. So convert the comparator. So whenever your voltage at non-inverting terminal is high compared to voltage at inverting terminal, then the output of op-amp is high. And when inverting voltage gets higher than the non-inverting terminal, then this output become negative. We call it low. So now suppose whatever input voltage I want to convert will be applied at this non-inverting terminal. Now, initially, because we can assume that the output of D to A converter is 0 because so far we are not started counting. So counter is in reset condition, 0 0 0 condition. So the output of D to A converter is also 0. So this comparator is on, that is in the high state. So this is high. So this AND gate we can apply clock pulses through this AND gate to this counter. So as clock pulses are applied to the counter start counting. So its count increases, okay, and the counters these counts, okay, and the output of counter is the input of D2A counter. So as counts increases, accordingly proportionally the voltage of V2D D2A counter with D2A converter will also increase. So here also voltage will increase. So this process will keep on continue until this voltage, the output of D2A converter, okay, until this voltage is become greater than or slightly greater than this voltage, this counter will start keep on counting pulses. So when and this voltage is approximately equal to this or slightly greater than this, then what will happen, this output will become low, we call it 0. So now this diode will not will stop supplying the pulses to this counter, and similarly this low output will set, okay, will command to the control circuit, and control circuit will reset the counter. So this output will come 0 0 0 0. Okay, let us understand this one. So when I say whenever this V input is higher than VDSC, this is high, and and the counter can count pulses. Okay, and once this V input become lesser than this V output of converter, then this will stop counting. So suppose if I want to convert this voltage into a digital output, okay, so I have to apply the counter will start counting, and it will apply pulses, clock pulses, and this is counting. Okay, once this is greater than this applied voltage, okay, counter will stop. Now suppose if I want to convert this voltage, again next voltage, to the digital output, again I have to start counting from the beginning. Okay, so as counting increases, the voltage is also increasing, so we can know, okay, what is the actual voltage. Okay, we can compare this voltage and we can find that this voltage is corresponding to what digital input. Now what is the disadvantage of this kind of counter? So you have to restart again. Okay, suppose you have done some analog voltage and you have you have converted into the digital input. If you want to get some other voltage, again you have to restart. Okay, so this is the slow counter. So instead of using a counter, you can use a up and down counter here, and then in that case, okay, you don't need to restart every counting again. You can start where you have left before. Now what about the maximum conversion time? You can see when you go from when you start counter start counting, and it measures the input voltage, it takes some time. Okay, so this time is basically clock pulses. Okay, so the maximum count, okay, the maximum conversion time for this converter can be is equal to the maximum input what we can apply here. Okay, so accordingly the maximum output here will be here. So the maximum output of this counter will be 2n minus 1. Okay, this counter can count up to 2n minus 1 pulses, because it's an n bit counter. So we can count up to 2n minus 1 pulses. So accordingly here the conversion time will be 2n minus 1 is t clock. T clock is the time period of the clock. Okay, so this way this counter counts the converts the digital input into analog, and the analog input into digital output. Thank you very much.